Hello guys, I am Engineer Muhammad Adnan Khan and you are watching my YouTube channel Being Engineer. Our today's topic is line of collimation method. It is also called as height of instrument method. So what is line of collimation? Line of collimation is actually the central axis of a telescope of a level. That is the line that passes through the center of eyepiece and object glass is called as line of collimation or line of sight, and the distance between the line of sight and the ground is called as height of instrument. So let's start our topic. I will explain it to you by an example. The following readings were taken with a 5-meter long staff rod. The things you have to keep in mind that the staff is 5-meter long and the readings were taken at consecutive interval of 30 meter. The distance between the two readings is 30 meter on a continuously sloping ground, and the ground is continuously slope from A to B. From A to B it is a continuous slope. Using HI method, find the slope while reduced level of a point A is 220.45 meter. We have to use HI method to find the slope of this line. Before finding the slope, we have to find the reduced level of point A and point B. So if we look at the example, the first thing that we observed is the staff rod is 5 meter long and the interval between two readings is 30 meter. That is, first reading after the adjustment of instrument we took 0.52, that is the first reading at point A. After that the second value, and the distance between two consecutive readings is 0.86 and the distance between two readings is 30 meter. Similarly, if we see at the data 0.5 to 0.86, the data is continuously increasing up to the point 4.00, and then we see a sudden decline in the value 0.26. Why this value declined? The reason is at some point the situation arises that our instrument lies below the staff rod and we are unable to take the reading. So in this situation we have to do what we will do, that is we will change the position of our instrument so that we can take the reading on staff rod. And if we change the position of instrument, we will have to make new HI, that is new height of instrument, as the height of the instrument may not be the same as it was earlier at this place. So we will have to make new HI. After 0.26 we see that the values are increasing continuously up to 3.85, and then there is a sudden decline in the value, because the same situation may have arisen that the level lies very low below the staff rod and we cannot take reading on the staff rod. The next thing that we have to do in this example is find the slope. And what is slope? As I have earlier explained in the previous video, rise and fall method, a slope is the ratio of vertical distance to the horizontal distance. Vertical distance, that is called as y, and the horizontal distance, that is x. We multiply it by 100 to get it in percentage. Slope is always expressed in percentage or in the form of ratio. So let's proceed. We have a table here. We noted the values. The first value we will write it in the back side, because the first reading after the adjustment of instrument is called as back side, and the last reading after the adjustment of instrument is called as foreside, and the values that comes in between are called as intersider. And this, as you can see, the value, the first reading was 0.52, second value is 0.86, and the values are continuously increasing up to 4.00. Here is the point where value declined 0.26. So this is the point where we change the position of our instrument, and we will write it in the remarks column change point, CP change for change point, and then we saw values again continue to increase 0.26 up to 3.85, and then there was a decline. So we took two values at the same distance from point A, so these two values will be written in the same row as these values. So the last reading was 0.38, and the reduced level of point A is given in the question in the table, which is called as benchmark. Now what is benchmark? Benchmark is any point of non-elevation, or the point whose level is known to us, or we already know its level. So this is the benchmark at point A. First step what we will have to do is to make HI. What is HI? Height of instrument is equal to backside plus benchmark. Backside is 0.52 and benchmark is 220.45. So by summing up these two values we will get HI. So to make HI I will use the calculator to explain it to you. 0.52 plus 220.45, we will get the HI, that is 220.97. Now to get the reduced level at this point, we will subtract 0.86 from this value. We will subtract 0.86 we will get 220.11. so this is the reduced level of this point, 220.11. now to get the reduced level of this point, we will adopt the same procedure, that we will subtract 1.78 from this HI. So 220.97, that is HI, minus that interside, minus 1.78, that comes out to be 219.19. Similarly, for this value we will subtract 2.02, 220.97, we will subtract 2.02 to 18.95. Similarly, to get this value, to get reduced level of this point, we will subtract 3.86 from this HI. We will get to 17.11. Now to get reduced level at this point, we will subtract 4.00 from this HI. We will get 216.97. So here we can see there are two values in this row. One is backside and another is foresight. Now this is the point where we change the position of the instrument. So here we will have to make new HI. How can we make new HI? That now we know that the reduced level of this point is 216.97. Now to get the new HI, we will use the same formula. HI is equal to backside plus benchmark. So the benchmark of this point is 216.97 and the backside is 0.26. So by adding 216.97 and 0.26, we will get the new HI, that is 217.23. Now we will use the same procedure, that to get the reduced level, we will subtract this value from HI, this value from HI, this value from HI, this value from HI, and here we will make again new HI. If we have the reduced level of this point, that is 213.38, we can make the new HI by adding this reduced level and the backside. We will get the new HI, that comes out to be 214.07. Now to get this reduced level, we will subtract 1.98 from 214.07. Let's use the calculator. To get the reduced level of this point, we will subtract 214.07 minus 1.98, that comes out to be 212.09. Similarly, to get this reduced level, we will subtract 2.38 from this HI. We will get 211.69. Now this is our last point, and we have completed and calculated all the reduced levels from point A to point B at the consecutive interval of 30 meter. These all readings are taken at the 30 meter interval. Now after completion of table, the next step is to check whether the calculation we have done is right or wrong. To check, we will apply these arithmetic checks. Number one is summation of backside minus summation of foresight. If we look into this table, there are 3 readings in backside and 3 readings in foresight. Sum of all these 3 values and sum of all these 3 values in foresight, we will write it here. It comes out to be summation of backside is 1.47 minus summation of foresight is 10.23. Similarly, the last reduced level, as we can see in the table, the last reduced level is 211.69 and the 211.69 and the first reduced level is 220.45. That is last reduced level, first reduced level. The difference comes out to be minus 8.76 minus 8.76. If these values are same, it's mean that the calculation we have done is okay, it's alright. The next part in the question was to find the slope. How to find the slope? To find the slope, we will have to know total horizontal distance. Total horizontal distance, as we know that we have taken the reading at consecutive interval of 30 meter, and the total number of readings we have taken, as we can see in this table, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the number of intervals will be 12 minus 1. So to get the total horizontal distance, we will multiply 30, that is interval distance between 2 readings, multiply by 11, that is total number of intervals, we will get the horizontal distance. To get the vertical distance is the difference between the level of point A and point B. That comes out to be 8.76. That is the vertical distance. Horizontal distance is slope is equal to, as we know that slope is equal to y divided by x multiplied by 100. Y, the value of y, that is vertical distance, is 8.76. Horizontal distance is 330 into 100. To get the slope in percentage, we will get the slope 3.06. It's mean that the difference between the level of point A and point B is 3.06%. That's all for today. Please subscribe my channel and press the bell icon to get new videos.